Okay, we're back with our Perkins engine with the mechanical fuel injection. You can see it has a rotary pump and it has a simple solenoid valve that controls the fuel supply. Now, in the earlier video, we showed how we used a Locktronics timing board with a few basic components to actually produce a time delay so that when we switched off the ignition, the engine ran on for approximately 30 seconds. So on the Locktronics board you can see we used two diodes, we used a relay and a warning lamp to let us know that the solenoid was energized. We used a transistor, a base limiting resistor and a capacitor. So the next logical step after this is to move these components onto a prototyping board. So there you can see we just moved everything over. Now we're using actual components. Again, we can see the elements there. We can see the relay, we can see the transistor, we can see the diodes, and we can see the warning light and resistor. So if we just operate the button again there we can see this, there's the circuit operating now. So as long as that light's on, when we switch off the ignition, as long as that light's on, the engine will continue to run, giving the time for the turbo to slow down to much slower speeds, so that when we eventually switch off the engine and the oil pressure drops, that the turbo is not turning too fast and being starved of oil. That's the whole idea behind this. So she should time out now any seconds. What we're doing here is we're waiting on this capacitor to discharge, which is just done. So once we've proven the theory again now with the actual components, the next step is to take the actual components and solder them onto some circuit boards. So here you can see we've soldered them onto some circuit boards, and you can see the same elements again. There's your capacitor, your transistor, your diodes, and your relay. And you can see here now this one's actually wired to the engine. So when I switch on the ignition, there I'm getting a feed to my fuel solenoid valve. When I switch off the ignition now, and you can see that the feed to the fuel solenoid valve is still on. Now this one is actually timing around for slightly longer, about 40-50 seconds. But again, it all depends on the value of this capacitor here and the value of the base limiting resistor that's connected in series with the base of the transistor. So we can mess about with those two values to actually vary the length of time that the engine will run on for. Now, having made it on this board here, the next step is, and we're still developing, is to try get it into a smaller bunch of components. So again, you can see the same basic elements are still here, except we've tightened everything up. So that's maybe for a later stage, or somebody on the next course might come along and decide, okay, I'm going to try to develop it from this point onwards. So we're going to look here, we're going to start the engine, let her run until she stops. So I switch on the ignition, and you notice there I have my lamp on indicating that the solenoid valve is being energized and I'm getting diesel fuel to the rotary pump. Now I start the engine, and then as soon as I start the engine and it's running, I'm going to switch off the ignition switch. And there we see our capacitor has discharged all its electricity and the system is no longer supplied. Solenoid valve closes, cuts off fuel, end of story.